1.2, solving problems using trig ratios. So we're going to recall SOHCAHTOA and angles of elevation and depression. Okay, elevation, when you elevate, you go up, right? And when you're depressed, you go down. Let's go and here. Okay, so angle of elevation or inclination. You may see it written as both. I'll personally write probably elevation. You may also see questions that don't even have these words in them. So there's no trigger. You have to be able to read them and then understand what's actually going on in the question. Okay, so what an angle of elevation is it is the angle of view from some horizontal. Okay, that's always going to be our reference, and it's going to be the angle up. Being viewed. Okay, so it's going to be from the horizontal up to the object being viewed. Angle of depression or descent, okay, could be used either one. I usually use depression. What this is it's like your line of sight. So like this person's eyes are here. So this is the horizontal line of sight. And it's going to be the angle going down to the object being viewed. Okay? The object being viewed would be from the person, not the ground. So a lot of times what ends up happening is they'll say like, okay, like Sally is 1.5 meters tall. So if they're 1.5 meters tall, what we're actually solving for is just from here to here. And then we would have to add the 1.5 meters afterwards. Okay, and then vice versa. So the height of the individual may have to be added or subtracted from the height found to find the total height. And remember, this is maybe. We have to read the question to actually understand. Okay, so let's go ahead and focus on how we draw these questions, the situations. Example 1, the highest point on a cliff is 98.5 meters. So say there's a cliff. Okay, so if we're considering it up and down, this is going to be 98.5. Okay, from the top of the cliff, so we don't have, so like from the top, sorry, I'm going to keep reading. A person 1.5 meters tall. So this person here is, now the height of this person is 1.5. Spots a parked car. So on the ground, there's going to be some parked car, okay, at an angle of depression of 40 degrees. So a couple things here. First of all, our height here is now no longer 98.5. Our total height is going to be 98.5 plus the 1.5. So it's actually going to be 100 meters because we're actually looking from here, like from that person's eyes right to the ground. So we're going to consider 100 meters. I'm going to write this down a little bit more. And now the angle of depression. So remember, this person's eyesight, we always have to consider the horizontal. The angle of depression means that we're going to go from the horizontal down 40 degrees. Okay, and that's how he views the car. Now our question is, how far is the car from the base of the cliff? So we're looking for this X value. So if this diagram is too confusing, what we can do is we can just draw a triangle. Okay, you can label it whatever you want. You can label it ABC if you want. Okay, we're going to solve for this X value over here. We have a height of 100. This is 90 degrees. Actually, I'm going to talk about this angle of depression. This is 40. If you remember in grade 9, the Z pattern, this angle and this angle are going to be the same. So if we actually look at this angle, make a huge Z, and here, this is going to be the 40-degree angle. Okay, and then we can focus in our attention here. So we are going to label our sides relative to the 40-degree angle. Okay, so 100 is going to be opposite, 90 degrees to 100 is going to be adjacent, and the longest side is going to be the hypotenuse. So when we take a look at SOHCAHTOA, we have the opposite, so we can't use cos because we need opposite in there. And then we need the adjacent. So TOA. So tan of C is going to give us opposite over adjacent. So our tan of 40, right, so we can sub 40 right in for the angle, is going to be 100 over x. We can cross multiply this x up. X tan 40 equals 100. And then to get the x by itself, we're going to divide both sides by tan 40. Remember, if you put tan 40 into your calculator, you're just going to simply get an answer, like a number, okay? So these two tan 40s cancel out. And for 100 over tan 40, we get 119. Let's just round to 119. And that will be in meters. So because this is a word problem, I'm going to go, therefore, the car is 119 meters from the base of the cliff. Example 2. A 1.5 meter tall person stands 8 meters from the base of a building. Okay, so I'm going to say, okay, so here's the person, and we accept that the line of sight, like this person's 1.5 meters tall. And then there's some building over here, and they stand 8 meters away. He measures the angle of elevation to the top of the building to be 50 degrees. So remember, we take his line of sight, right? So from here down is 1.5 meters. Now, the angle of elevation is from a horizontal up to whatever he's looking at, okay? So that's going to be 50. How tall is the building? So if this is a little bit confusing because we're trying to find how tall the entire building is, but we're actually only going to be able to find from here to here using this triangle. So if this is too confusing, what we can do is we can duplicate this. Let's go over here. That's fine. Okay, we can label it 50 degrees. How tall is the building? Let's call that X. And this is going to be 8. And we can just label it with ABC. And everybody might have their own labels like ABC, and they may not be the same as your partner, but that's okay. So from here, we're going to label opposite, adjacent, and hypotenuse, and then solve for BC, which is like our X, the height of the building. Okay, well, the height of this part of the building. So opposite 50 degrees is going to be the X, and then adjacent is going to be the 8. Okay, we can label hypotenuse, but we already know that we're going to be using opposite and adjacent. So when we write out SOHCAHTOA, the opposite and the adjacent are with the tan. So we can write tan of 50 equals opposite, which is X, over adjacent, which is 8. Bring that 8 up with the cross multiplication. and we get 8 tan 50 equals x. And then if you throw that into your calculator, we get x equals 9.5. Okay? Going back to the original question, the 9.5 is only from the top of the building to the horizontal of that man's site. So we have to then consider the total height is going to be 9.5 plus 1.5. So we get 11 meters. So therefore, the height of the building is 11 meters. In construction, the pitch of a roof may be given as 7 to 12 in feet. Okay, this means the maximum height of the roof is 7 feet. Okay, so we see this height here, 7 feet, maximum height. And the distance from the midpoint. So midpoint would be like, if we were taking a look at this entire roof, midpoint is like the middle. Okay, to the base of the roof, sorry, the midpoint of the base of the roof to the outer wall is 12 feet, which is where this number comes from, okay? Calculate the roof's angle of inclination. So angle of inclination is going to be from the horizontal up. So this one's quite easy, okay? If you only want to look at the triangle, we can just take a look at that. We can label this A, B, and C. We have 12, we have 7, and then we can solve for A. So if we are trying to solve for angle A, 7 is opposite, 12 is adjacent, and that's all we need, right? This is hypotenuse over here, but we're dealing with opposite and adjacent. And we know from the previous question, example 2, we're going to be dealing with tan. So tan theta equals opposite over adjacent. So tan of angle A equals 7 over 12. Now, if we put 7 over 12 in our calculator, we are going to get a very long, ugly number, 0.583333, and continue. So to reverse the tan, because we want to get A by itself, we are going to tan inverse both sides. Remember, what we do the left-hand side, we do the right-hand side. And tan inverse cancel out. And when we tan inverse this side, we get 30 degrees. Okay, so therefore, the roof's angle of inclination is 30 degrees.